let's talk a little more about how to use a matrix inverse. So we've got this system written out here, and we can write it if we want to as a matrix equation, ax equals b. So if we do that, we'd have the matrix, let's see, 2, 3, 2, 1, 1, 4, 3, 4, 1 times the vector x is equal to 9, 4, 2, where this is my A and this is my B. I'm putting arrows over the X and the B because they're vectors. The X here, you could think of if you wanted to as X being the matrix containing X, Y, Z like that. I realized I called that a matrix and I called it a vector. A vector is just a matrix. It has a single column or a single row. All right, so if we wanted to solve this, one way we could do it would be to find the inverse of A. Because if we've got A, if we have the equation AX equals B, one way to solve that is by multiplying A inverse on the front. If we know A inverse, notice what happens over here. These go together and just give you the identity matrix times X, which is the same thing as just X, equals A inverse times B. So if we know the inverse of this thing, then we can solve this system by just by doing a matrix multiplication. So let's use octave to find that. All right, let's see, I'll still call it A. So our matrix here is 2, 3, 2, 1, 1, 4, 3, 4, 1. And so that's our inverse. So to solve this, what we could do is just do A inverse times B. I guess that doesn't really change stuff a whole lot. But what was our B matrix? 9, 4, 2. So on here, if I take A inverse times 9, 4, 2, it gives us this. Negative 19 14.2 and 2.2. And that's our answer. Now you might say, what's the purpose of doing this? Why wouldn't I just type it in as an augmented matrix and solve that? Well, there's no real reason to do one or the other if you're only solving a single equation. But suppose they gave you this and then they also gave you another thing to solve. Say that after you did that, they say, okay, now solve 2, 3, 2, or solve this system with, I'm just going to make up three numbers here, 7, 8, and 7. Well, if we want to solve that now, since we've already got our A inverse here, what we can do is come back over here to octave and just change one thing. Whoops. Change one thing. The matrix we're multiplying by. And that gives me X, Y, Z is 1.6 and 1.6. So matrix inverses are useful for things like this, where you have to solve a system several times. And I think we'll stop here.